Hey everyone, my name is Itai. I'm the VP of Solution Architecture at Bit. In this session, we'll be primarily focused on using Hope AI, Bit, and a slew of other open source tools to take a design built in any design tooling and essentially transform it to a component that can already be integrated and used in basically any application as a simple dependency. Without further ado, I just would like to get started. All right, so I already have set up an account for myself on Bit Cloud, and here I can start my session with Hope AI. I'll start by pasting here a prompt that I have already made, but I'll go over all of the contents of it before we paste it, before we run it. All right, so what we're going to do is we would like to take this mock, from our designers and transform this to a component we can put in any application we want, because we may have multiple landing pages in different applications that we need a functionality for this, and we know we need something reusable. What we want to say is build the following signup newsletter component, which will use the attached image as a design reference, and let's attach the image. The signup to newsletter component should be in the marketing scope. So it's important to understand that in Bit, components are sorted into business domains maintained and owned by different stakeholders. The marketing scope meaning the marketing domain. Here, we actually want the AI to focus on only implementing the UI, not handle any connectivity to external newsletter services, but we still need to make sure we have an API that can provide us with a sort of on-click functionality to be triggered once the user submits the form. So essentially, any application can pick and choose which newsletter service they want to use, but they can still use the same consistent reusable UI. If you want a little bit more complex or advanced cases, obviously we can ask the AI to give it, to have this readily integrated to a specific service or whatever. But for this example, I would prefer to keep it simple. Now, because we're aiming for something to be highly reusable, I also made sure to highlight to the AI that, I want to make sure that all the text and content and things in the design should be fully customizable to end user using props and using APIs. And once I have my prop ready, my mockup uploaded, I'm just gonna send my prompt to the AI. Now, the way you want to think about Hope AI is similar to how you would first interact with an architect and later on with the developers who will build that. So what Hope does when you prompt to it as an architect, before it generates any code, it starts building an architecture. And then later on, once you agree on the reasoning behind the architecture, then Hope AI will start implementing all of the components in the composable architecture. And let me show you quickly how this works. Basically, with this in mind, we optimize for reuse instead of generating new code. This way we can both save money, save time, and get more consistent valid results. Because if we have components that are already available for us to be reused in our architecture, we're not going to regenerate them. We're just going to use them. So broadly speaking, Hope AI follows a fairly simple algorithm. So it checks if a component exists. If it does, it retrieves it, and it can also refactor code as needed. Otherwise, Hope builds a virtual dependency graph to orchestrate the overall architecture of solution it wants to build. And for each dependency, it looks for if that piece of code, piece of functionality exists. If it does, fetches it and uses as dependency. If not, generate it and kind of go through this recursive flow. Let's see it in action. So here, let's say we have a fairly basic prompt about building a basic header component that fits a design system. Obviously, in this use case, we already have a design system that Hope AI is familiar with. So the first thing Hope does is build a sort of architecture, right? The user requests for a header, and then the header needs to be composed from a logo, avatar, menu, and search box, which all of them are potential dependencies. So Hope goes through all the components and starts to see if they are available. So logo is available. That's great. We're going to use this as a dependency. Avatar is missing. Avatar is a fairly simple component. There's not too many dependencies we need. So we're just going to generate one. Menu is available, but the API, maybe, it's not quite there. It needs some modification. It needs some refactoring. So instead of generating a new menu, Hope simply suggests the modifications to the menu component. Lastly, the search box is missing. To build a search box, we'll need a button and an input. So we're going to search for them as potential dependencies. We found both of them. So now we can implement search box by simply reusing and composing together button and input. So we have that. Now we have all of our dependencies aligned, and we can generate header using all of these components. And this way, the only code that we actually generated, the only interaction we ever did, the only tokens we spent are about, generating the avatar, doing some fixes to the menu, generating the search box from two existing components, and generate the header from other existing components. So we generate far less code and we operate in a far more concise and specific way, which can be far more consistent because we work with the premise of a single design system. We have our logos, we have our avatars, with our menus, with our buttons. We do not need to regenerate them constantly. And if we zoom out a little bit, this small dependency graph also lives in a wider architecture. So, you have your app, your different pages, or others that can use those components and others as they build code. And this way, you only deal with a small delta of new code or refactor code needed for your feature. So with this in mind, let's see what Hope AI generated for us as the architecture. So as mentioned here, the first thing we get is we get our architecture. Let me zoom in just one bit, or 2 bits. The architecture is comprised of 10 components. Some of them are design components because in this account, this is a fresh account. There's no design system. If you already have a design system, you can load that design system to Hope AI and onboard Hope to use your design system. There's documentation on that, but this is kind of beyond the scope of this webinar. So we'll try and not focus on this one as well. Or if you are already using Bit or Bit Cloud and you already have components, and you can check this with other teams in your organization or your developers in different teams or in your team. If they already use Bit, Hope AI will know to use their components. So again, things will be far more consistent with the new code that you are generating. And we also see the marketing domain with the sign up to newsletter. All of these components are not yet generated. What we've done is we simply have an architecture. Now I can continue on prompting to Hope to maybe iterate a little bit, add some component, remove some components, consider some functionality. But before we do that, let's see what Hope wants to do with each component. So the first component, which is probably one of the most important ones, is our theme. Let's expand this. And we see there is a dedicated prompt on how Hope wants to build and generate the code for the theme. I can edit the prompt. I can even attach additional content into this. So in this case, I actually pulled all of my design tokens. I asked my designers to bring the design tokens in a PDF format. Let's open them, right? All of the design tokens are available. And I would like Hope to understand all of my tokens, so it will use them as it builds the theme. So let's also edit the prompt and mention to take all tokens and values from the attached file and save. We can also go a little bit deeper into the button component. We see that the button component also has its own prompt and what dependencies it will use. So it will use the same theme, it will use the same link, and the development environment that was generated. And maybe we'll have some time to touch on this one. The last component is the sign up to newsletter, which obviously has a far more robust prompt because it's a far more complex one, has a lot more dependencies. And even here, we can reattach our mock, so we'll have a stronger reference. Now, had we had the time in this session, I would go through each of the components. And if I was able to, I would add additional resources and assets to showcase all the states of these components, because once they're generated, they are reusable for me in every project. So I can better use them and utilize them the more fine-tuned they are to my needs with my design system. But in this case, it's going to be enough for me just to do this. Once I'm satisfied with all of my architecture and with my specific prompts on per component level, I can start generating. Now, so if I mentioned that, you can prompt to Hope as an architect, when you prompt on a specific component, you basically speak with a quote-unquote developer. So there's 2 layers for how you do your design to code flow, and that's kind of how you do it. So let's say we're satisfied and we'll start generating. Now, because I don't want to wait for everything to be generated, because we are kind of short on time, I want to go into some of the code that's already generated with the same prompt. For each of the components that you see here that is generated, we can see a dedicated card and information on that component. And let's go all the way to the sign up to newsletter, the final component we are here to generate. And let's see what we got. So first of all, we see the component has 100% code coverage. We see that there is a package we can actually install and use as a dependency. We'll show the previews soon. And there's full documentation generated by Hope AI to make sure you can use it. And as mentioned, all prop types or all props, sorry, are available for you to customize this for any use case, including the on submit and all text here. Those different minimal ones, and we can see the different previews for this. Okay, so we see a basic one, we see a more customized one, and a more minimal one as well. We can even see the dependency graph with all other components that depend on it. And more importantly, the API reference. Let me zoom out a little bit, right? Where we can see exactly how to use this in different projects. Now, once I'm satisfied with this, or if I'm not, I can go ahead and click on Edit Code and actually get an in-browser IDE in which I can manually modify each line of code I want, and I can optimize this to my need. And while we are here, we can see that Hope also generated tests and the documentation in an MDX format, and even all the usage examples are available. When running this code through CI, Hope also make sure that every test are running, all of your code has the most quality gates available to it, so you can trust this code to run perfectly in different use cases, or if needed, you can add more code. And from here, we can actually take this and integrate into any Git repository, so we can have developers using local development tools to iterate on this, built on either Reusable CI, which is a part of Bit Cloud, and again, not going to touch this feature in this webinar, or build on your company's CI, whether you're using GitHub Actions, GitLab, Jenkins, or whatever other tool you're using. So, and once all components are available, are built, essentially they will be available on Bit Cloud to consume as packages, as dependencies for any other project. So, if before we saw all the previews and things are generated by Hope AI, here we actually see the marketing domain and our sign up to newsletter component. We can see that we can install it with PNPM, yarn, and PM. We can see that there can be multiple versions for this component. We can see the changelog for it. We can even compare between versions. We can see the code behind. We can see all the test results and even test coverage for the component. So we know we can trust this. And one final piece, it's not just about generating those reusable components, because we also want to make sure it's very easy to use those components. So let's head to VS Code for a quick demonstration. One key feature that Bit and Hope AI provides when developing locally is the ability to use those components using a Copilot agent or Cursor, Roux, or any other code assistant agent that you may use. So to do that, Bit utilizes an MCP, and let's initialize this. So so what you need to do is to make sure that you have Bit open source installed on your client. It's an open source tool. It's been widely used by various people for building anything from design system components to MFEs into full-blown full-stack applications. And now it features also an MCP. So we'll run Bit MCP server setup as a consumer project. This sets up, MCP server. Okay, and we're also gonna set up our instructions, our rules. And we see here all the rules and settings for them. One thing important to mention here is we want to make sure that we set up the right account on which our components are hosted on Bit Cloud, because there can be multiple projects, multiple companies operating there, and there is some gatekeeping on permissions on where you can use. And in this case, I also want to add instructions to use PNPM for package management for this project. Let me save my instructions. Now, this is my index file, and here I would like to see if and how I can use the component we generated. So I open Copilot, and I'm just going to move this to agent mode. And let me also validate that my MCP server is running. All right. Now I can say something like search for a sign up to newsletter component. And what we see is that Copilot can now use the Bit remote search functionality to find remote components to fit my use case. And it definitely found the marketing sign up to newsletter. It's a description, and it also has access to all the documentation and metadata for this component, and even information on the dependencies. This means that if I want to implement, the newsletter sign up feature in my app, I can say something like implement a usage for the newsletter component in my app. My app is a gamer community. All right. So Copilot will want to install the package. So we'll let it continue. And once it's installed, and as you saw earlier, through the MCP, the agent has access to understand all the API capability of the component. So it can build us a great usage example, and even, what to do with when newsletter sign up happens. And I can keep this if I like it, or, I can engage with the AI to get a little bit more things for my specific needs. And all of that without even actually writing a single line of code around this sign up to newsletter. Because just as a reminder, we only took the mock information and, we uploaded the tokens and went with it. Right. So before we move into questions, I would like to showcase one last thing just to show how far this can go. All right. So on a previous session, I also wrote this prompt to OpenAI. So I want to build an app for a clerk managing a drive-through window on a 24/7 bodega shop. The clerk should be able to take orders, submit invoices, see what's in storage, and I don't want to handle storage management. This is for a different system. And here, let's see the architecture that Hope built for this. So we see that Hope wants to generate 85 different components, and let's quickly go over them before we have a chance to go over questions. So again, there's no design system. So Hope wants to generate a design system and all components for it. Hope also wants to build your order management, right? So all the front-end UI pages, even hooks to use the different data entities from the backend, and admin portals for order management. Each of them will have its own prompt, and even a full-blown feature with CRUD operations on top of databases, MongoDB in this case by default, where we can actually look at orders as its own independent standalone feature. And because Hope breaks down the complex problem of building that app into smaller manageable pieces, and each of these pieces will have its own tests, documentation, LinkedIn rules, and so on, we can better trust that the code we're going to get is of far better quality and going to actually run together much smoother and, potentially with far less operations, or far less fixes to do. Thank you so much.